Good morning all. Today we are going to see about the Compton effect and the derivation related to Compton effect. So what is Compton effect? When a photon, that is when an incident photon hits an electron at rest, the energy or the frequency of the electron will get reduced. Why? Because that electron is going to hit the electron at rest and the electron going to get some energy, so it's going to move in one direction, as well as the scattered photon will move in another direction, creating an angle theta and phi. Okay, so what are the things involved in Compton effect? Initially we will be discussing about the energy and momentum in both the cases, before collision as well as after collision. Okay, so before collision, what will be the energy for this electron at rest and incident photon? Similarly, what will be the momentum for the electron at rest and incident photon? Similarly, after collision, what will be the energy for the scattered photon and the recoil electron, as well as the momentum for the scattered photon and recoil electron? Once we get the equation or the formula for this two, we can start the derivation. Okay, so for the easy convenience, here have been listed out the energy and the momentum formula before collision as well as after collision. So before collision, the energy of the incident photon is h nu, whereas the energy of the electron is m naught c square. The momentum of the incident photon. In general, what is the formula for momentum? It is P equal to h by lambda. We will substitute the value for lambda as c by nu. So the formula for momentum will be h nu by c. Whereas momentum of electron, since the electron is at rest in the before collision part, the momentum of the electron is 0. Now we are going to consider what will be the energy and momentum after collision. The energy of the scattered photon will be h nu prime. The basic difference and the understanding between this nu and nu prime is the incident photon energy or the frequency will be higher than the scattered photon. Okay, so that is the difference between h nu and h nu prime. The energy of the scattered photon is h nu prime. The energy of the electron is mc square. The momentum of the scattered photon is h nu prime by c. Similarly, now the electron is going to have some momentum. So here we will be writing the momentum of electron as mv. So now we will be considering two cases, that is conservation of energy and conservation of momentum. So first we will consider the energy of system. So system in sense we are going to consider the electron and photon together. So we are going to add the energy of the system before and after collision. So energy of the system before collision is h nu plus m naught c square, whereas the energy of the system after collision is h nu prime plus mc square. According to the principle of conservation energy, we can equate the energy of the system before collision and after collision, so that h nu plus m naught c square, which is equal to h nu prime plus mc square. So from this equation we are going to write only mc square in one side. So automatically this h nu prime will come to the other side. So we can write the equation as h nu minus h nu prime plus m naught c square. Let us consider the equation as 1a and 1b respectively. Now we are going to consider the conservation of momentum part. Here the whole reaction is going in linear momentum. So according to the principle of conservation of linear momentum, along as well as perpendicular to the direction of the incident photon. What is along as well as perpendicular? We are going to consider x and y axis. Okay, so what will happen to x axis? In x axis the momentum of the electron is 0, whereas the momentum of the incident photon is h nu by c. So before collision we will be having the LHS as h nu by c plus 0, whereas coming to RHS along x axis, here the electron is going to create some angle theta, as well as the scattered photon will create some angle as phi. Since it is x axis, we are going to consider the x component. So we just recall the components for x and y axis. For x axis it is cos theta, whereas y axis the y component is sin theta. Okay, remembering that in mind, we are going to write this part. h nu prime by c is momentum of the scattered photon, which is along x axis. So we are considering the x component as cos phi. Similarly, the electron momentum will be written as mv cos theta. Okay, this part is after collision and this is before collision. That's why the electron of the momentum is 0 here. So now we rearrange this equation, having mv cos theta part alone in one side and h nu prime by c cos phi to the other side. So what will happen to this equation? H nu by c minus h nu prime by c cos phi. So let us take the c as common and taking that c to the other side, the equation 2 will be mvc cos theta, which is equal to h nu minus h nu prime cos phi. This is the momentum part for x-axis. What will happen to the y-axis? In the diagram we saw that the incident photon as well as the electron are considered in the x-axis. So in this part we have some value, whereas for y-axis there is no case involved, isn't it? So before collision part we will not having any y-axis term. So along y-axis the momentum part in LHS will become 0. So what will happen to the y-axis? As I discussed earlier, for y-axis we will be considering the y component, which is nothing but sine theta or sine part. Okay, so what will happen here? The scattered photon will have the y component as h nu prime by c sine phi, whereas the electron will have mv sine theta. So what is this minus? How the minus part came in? It is in sense like we are going to consider this minus x-axis, minus y-axis. I'm sorry, this is minus y-axis. No. So here we are not considering any part in minus x-axis. So we will not get any negative sign earlier. So now the electron is going to consider in minus y-axis. So we will be writing this part as minus mv sine theta. Again, take this h nu prime sine phi by c in one side as well as mv sine theta in another side. So the equation will be mv sine theta, which is equal to h nu prime by c sine phi. Taking c to the other side, we will get equation number 3, mvc sine theta, which is equal to h nu prime sine phi. Now we are going to square equation 2 and 3. Equation 2 and 3 are nothing but the x-axis and the y-axis components. So what will happen here? First squaring second and third equation, then we can add. So let us consider the LHS first. Here the LHS is mvc cos theta. Once we square this, we will get m square v square c square and cos square theta. Similarly, here the LHS is mvc sin theta. If we square this term, we will get m square v square c square sin square theta. So let us take the common m square v square c square as common. So inside the bracket you will get cos square theta plus sin square theta. This is for LHS. What will be the RHS? Here the RHS is h nu minus h nu prime cos phi. So squaring means you will take this term in the bracket. So h nu minus h nu prime cos phi square, then adding, so add plus the third equation h nu prime sin phi whole square. So here we are considering a minus b whole square formula. As we all know, a minus b whole square, which is equal to a square plus b square minus 2ab. So here the a is h nu and b is h nu prime cos phi. Okay, so you can see how we are writing this part. Okay, so h square nu square plus h square nu prime square minus 2 h square nu prime cos phi plus h square nu square sin square t phi. Okay, so taking the common h square outside, you will get nu square plus nu prime square minus nu prime cos phi. Okay, so this you can take as equation number 4. Okay, now squaring 1b. 1b is nothing but the energy conservation. Here mc square, which is equal to h nu minus h nu prime plus m naught c square. Now squaring this term, you will get m square c square into c square, so c power 4. So m square c power 4, which is equal to squaring all the term. So together we are going to put this square term. Taking h as common, you will get the first term as h nu minus nu prime plus m naught square c square. So now this is again going to give you a minus b whole square formula, whereas h square will be taken as common. Here what will happen to the second part? m naught square c power 4. Okay, so consider this equation as h square nu minus nu prime whole square plus m naught square c power 4 plus 2h m naught square c square nu minus nu prime. Okay, so a plus b whole square formula, we are just applying this. Here again you will get another formula, a minus b whole square. So expand this part as a square plus b square minus 2ab. Okay, so initially it is together as a plus b whole square, so we applied that a plus b whole square formula. Then this part alone, a minus b whole square, so expanding this nu minus nu prime dash whole square as nu square plus nu prime square minus 2 nu prime. Okay, this will be equation number 5. Now we are going to subtract equation 4 from equation 5. So on subtracting, what will come the LHS? M square c power 4 minus m square v square c square, which is equal to this whole term minus this term. Okay, so on doing all the, by taking all the common parts outside, you will get this m naught square c power 4 will be the same as such. Similarly 2h m naught square nu minus nu prime, so this 2 term will not get altered at all. So this part as well as this part alone will get altered. So if you take this part minus this h square nu minus nu prime square minus 2 nu prime cos phi, you will get 2h square nu prime cos phi minus 1. Okay, so now we are going to consider the theory of relativity. According to the theory of relativity, m is equal to m naught by root 1 minus v square by c square. What will be the m square term then? It will be m square, which is equal to m naught square by 1 minus v square by c square. Now we are going to rewrite this equation. Instead of m square in the previous equation, in LHS part we got this m square term. No? We are going to rewrite this m square as m naught square by 1 minus v square by c square. So that's why I have written this LHS part alone. So instead of m square, can substitute m naught square by 1 minus v square by c square into c power 4 minus, again going to substitute the value for m square, so m naught square by 1 minus v square by c square into v square by c square. Okay, so now we are going to take the common parts outside, which is m naught square c power 4. So here in the second term we are not having c power 4, isn't it? We are having only c square, so we can divide that term. Okay, so what will happen to the first term? If we take m naught square c power 4 as common outside, we will get 1 in the numerator and the denominator will be 1 minus v square by c square. Similarly, coming to the second part, we have m naught square, whereas we have only c square, so we are dividing c square. So v square by c square, again the denominator part will come as such. So now you can see the denominators are common, so you can take the denominators common denominator, so you can combine the numerator. So it will be 1 minus v square by c square, again the denominator is 1 minus v square by c square, so this part will get cancelled. We will get only m naught square c power 4. Now we are going to use this m naught square c power 4 instead of your LHS term, which is m square c power 4 minus m square v square c square. So instead of this, we are going to substitute this part. So we can take this as equation 7 and the previous equation as 6. You can substitute this equation 7 in equation 6. So the LHS term will be m naught square c power 4 and the RHS term will come as such. Okay. Now this m naught square c power 4 and m naught square c power 4 in LHS RHS will get cancelled. So this 2 term alone we will be considering. So taking one term to the other side, so this part will become minus 2h square nu prime cos phi minus 1. So again cancel the common terms, 2 and h will get cancelled, whereas in the RHS we have h square, so we will have 1h, isn't it? So here you have negative. Once you want to consider this negative as positive, just interchange this. Cos phi minus phi can be written as 1 minus cos phi, so that the negative sign will get vanished. Okay, so once we cancel the common terms, we will get nu minus nu prime m naught c square in one side, as well as minus nu prime cos phi minus 1. So in order to remove this negative sign, we are going to rewrite cos phi minus 1 as 1 minus cos phi. So nu minus nu prime, here you have nu prime. So taking this to the other side, it will come as denominator. So here you have only h and m naught c square will come to the other side. So it will be written in the denominator. So now consider this LHS. This is nu minus nu prime by nu minus nu prime. So you can give this denominator for these 2 terms individually. If you give as such, the common terms will get cancelled. So the first term will be 1 minus nu prime minus 1 by nu, whereas the RHS will remain the same, h by m naught c square 1 minus cos phi. Okay, now this equation is going to purely depend on frequency. We can also write this equation with respect to lambda, that is wavelength. So 1 minus 1 divided by frequency, 1 by nu is nothing but lambda. So instead of 1 by nu prime, we can write lambda prime 1 by nu as lambda. Okay, so this can be written like nu prime is equal to c by lambda prime and nu is equal to c by lambda. Okay, so here you can write lambda prime minus lambda, which is equal to h by m naught c square 1 minus cos phi. This is equation number 9. So from this we can say that the incident photon will have a frequency of nu. Once it hit the electron, the nu will get reduced as nu prime, whereas the lambda will get increased. So whenever an incident photon hits an electron at rest, the scattered photon will have some reduced frequency or longer wavelength. So the electron which is at rest will have some energy and it starts to move with some velocity. And in general, we have to consider this part that once it gets hit, it will move in different direction, creating different angle. Okay, so we just quickly recall what are the things we need to remember in Compton effect. First, the equation. Secondly, remember this diagram. So consider both before and after collision part, and we have to write the formula for energy and momentum for the incident photon and electron at rest for before collision, and for after collision we will be considering scattered photon and recoil electron. Once we know the formula, we can apply the two conservation laws. One is conservation of energy and momentum. So once we know the x-axis and y-axis component, we can do all this mathematical step. Thank you.